This is using Bazel for fast, correct Docker deployments. I'm Matt Moore. I am the Uber TL for container development at Google. And two of the things I'm passionate about are really tight development cycle and better ways about building container images. And hopefully you walk away today understanding how those two things are very related. And
cool. Hi, everyone. My name is Miles Yucht. I'm a software engineer at Databricks, and I feel a little bit out of my league around all of these like build people, Bazel people, but hopefully I can tell you a little bit about how I'm, as just a software engineer, have been able to use Bazel to be really successful with deployment at Databricks.
All right. So before we dive in, just a quick outline. I am going to start off and talk about the evolution of building Docker images with Bazel and how that has more recently evolved into deploying images with Bazel, and give a quick demo and then hand things over to Miles.
And I'll talk about a rule that I've written at Databricks to help automate the deployment of many of our services that we run.
Then we'll open things up for Q&A. So, the origin story. Where did it all begin? So, building Docker images with Bazel started 2.5 years ago. And it started as a tool to enable Googlers who were targeting cloud to build Docker images. And in a way that sort of integrated naturally with our internal tool chain, which can be opinionated and is very principled. The biggest constraint we faced was that some of our opinionation and whatnot, all of this stuff runs on top of our internal production infrastructure. We don't let people run root, so we couldn't run the Docker daemon. And so this ruled out every traditional method for building Docker images. The solution we built adheres to our sort of Blaze's principled approach of reproducibility, as well as some of our internal principles. And these rules were pretty quickly actually open sourced by the, at the time, very relatively new Bazel team. But the rules that were open sourced at the time had a problem. They were incomplete. You couldn't pull down a base image or publish the result without having a Docker daemon. So we actually had push support internally as well, but it was using a library. We hadn't open sourced yet. And so we hadn't quite open sourced that rule. Because of some of those principles around hermeticity, we couldn't have pull because we don't have network access. So earlier this year, as I sort of turned my focus towards what it looks like to use these rules in the open, we wanted to complete this cycle. And so we implemented pull using that now open source library, and we open source push support as well. And then with this sort of more complete end-to-end, the focus turned towards making that easier to use and making that faster. And we've already made a number of significant improvements just under the hood in terms of how these work to make it faster. In the pursuit of perfection, right? Like it's never fast enough for me or easy enough, right? We introduced these Lang image rules. The idea behind these, the aspiration was to make containerizing an application, once you've reached the level of expressing it as Lang binary, right? Java binary, Go binary, whatever. As easy as replacing the word binary with the word image, right? It's the dream, right? The idea is that you've already told Bazel all this information about your dependencies and the environment, the platform you are targeting. And so for at least, I would say, a majority of simple cases, we should just be able to do the right thing without you needing to tweak a whole bunch of knobs. And so my personal goal is to get containers back into sort of place of being an implementation detail. And there's been a ton of hype It's since the rise of Docker. If we were to do this Family Feud style, and Googlers have been using containers, knowing it or not, for a really long time. If a couple of years ago, before all the hype around containers, you had asked them, how we ran things in production, Survey would probably say things like deploy jar and par files and whatnot. I don't know that most Googlers would have jumped right to containers. And so really, they're an implementation detail. They should get out of your way and enable you to do what you're really after, which is just running your app. So easy was not the, sorry, I advanced before segueing. So making it easier to use wasn't the only reason that I wanted to introduce laying image. It was also to enable us to take over the containerization process, right? So you can see in the example on the left, we've deleted this sort of Docker build that just throws the binary in a Docker image and sets the entry point. We can do more sophisticated things if we're in control of it, leveraging the deep knowledge of the build graph. And the aspects sound really cool. I haven't played with them yet, but I kind of want to for this. But so ultimately, for those of you who have used Docker before, right, when you push an image or you pull an image, you'll see messages like layer already exists. This means that Docker has checked for the existence of a layer on the remote registry or in its local layer cache, and it is avoiding work because it's already done. So if you think about it, within the Docker distribution protocol, layers are the unit of incrementality, right? And the way this is typically leveraged is you have a common base image, and two sibling containers can rely on that fact to get better, if they're running in the same pod, not pull things like Debian and the JRE twice, right? You share a common base and you get the benefit of that. The way I started to look at it was, if you look at an application over time as you change it as siblings, right? How do I minimize the delta between my app now, my app in 5 minutes, my app in 10 minutes, right? Ultimately, we want to minimize that change so that pushes and pulls are really, really, really fast. And so there's a duality here to build incrementality, right? Incremental builds are a very well-studied problem. John might argue it's solved, right? We wanted to take, all of the fine-grained information that exists in the action graph and effectively project it into the layering of your Docker image to turn the build system's incrementality into deployment incrementality. So if you look at this example that's up on, the left, you can have a relatively small application that builds on top of really big libraries, right? So in this example, this is from the rules Kubernetes repo. It's a sample gRPC service. It uses the gRPC IO requirement, which is like 40 megs. The app itself, including a bunch of generated code, is less than 400K. So by moving some of these big dependencies into their own layers, because they aren't changing, you reduce what you push by about 2 orders of magnitude. So the intent is to ultimately reduce what it is you're paying for when you push and pull during your development cycle to exactly what you're changing, right? Which is, again, a lot of similarities to build incrementality, right? Minimizing what you rebuild to exactly those things affected by your changes. I've been talking a lot about push and pull. Ultimately, while pull, build, push is sort of an end-to-end, your cycle really doesn't stop until you reach the point of running it on a node and getting the feedback of playing with your app, poking at it, running some sort of tests against it. And so we haven't connected the dots between publishing your image and pulling it onto some sort of runtime system. And that's where the next rule comes in. Kubernetes object. So Kubernetes object allows you to reason about Kubernetes resources within your build graph. There's sort of 2 classes of Kubernetes object. There's your pure config, like config maps, ingress, and so on and so forth, services. And then there's objects that reference container images, such as deployments, pods, etc. The ones that reference, so all of these are typically expressed in some sort of YAML or JSON config. The rule takes a pointer to that template. And optionally, you can augment that with a mapping from the image references that it might exist within the template to build targets that can produce them. And this effectively connects your Kubernetes resources into the build graph in ways that enable you to reason about what Kubernetes resources are affected when you touch a source file, right? You can now, we then leverage this to, on these Kubernetes object rules, export actions that allow you to interact with these resources in a single command that, again, my goal is very, very, very fast. So these actions look like dev.create, which will build all of the images. And again, this is run, not build. It will publish them, and it will kubectl create the resource template after inlining the digest into the template. If I now want to make a change and see that in action, I can run Bazel run dev.replace, and it will rebuild, repush, and redeploy my changes as quickly as your build executes, basically. For those of you who are of the kubectl apply religion, you can use apply as well. I have no skin in that game. And then when you're done at the end of the day, you can run Bazel run dev.delete to tear down. So two more things before we move on that I just want to touch on, but am not going to get into in any more detail. See me afterwards if you want to talk about these. There are a number of features of these rules that enable you to have different development environments for different developers on your team, so you aren't stomping on each other. We'll touch on one of these during the demo. And the other piece is that the resource template does not have to be static, right? These rules are intended to be able to compose with other rules that support templating, like rules JSON it. OK, so one last thing before the demo, which is, looks very similar, but it's plural. Once you start to deal with non-trivial Kubernetes applications, you start to deal with multiple objects. And so the way some people do this in Kubernetes land is you have a single .yaml file that conjoins together a whole bunch of YAML objects with in a multi-document YAML file separated with dash, dash, dash. This could be really nice for installing someone else's application, like Istio or something, onto your cluster. But if you are doing development, it's really inconvenient to then go in and try and replace one of those objects when they change, because you have to separate it out. And so I wanted to deal with sort of that problem. And so we introduced the K8s objects rule to deal with that. And so in order, excuse me, in order to deal with objects at multiple levels, we have the individual resource rules, but the objects rule enables you to start grouping these things to reason about them in larger and larger groupings. So you can group together all of your deployments, all of your config maps. You can group together everything. And so this pluralized object allows you to act on that group of objects with the same set of commands. So I can say Bazel run everything.create and stand up an application at the beginning of the day. At the end of the day, I can say .delete. It'll clean everything up and go home, start again in the morning. And during the day, I can say replace on one of the individual objects, and it will do the right thing. So hopefully I'm doing all right on time. OK, I'm actually doing really well. OK, demo time. So for the demo, we are going to, OK, everyone see this? We are going to be using an application called Prow. This is maintained by the Kubernetes SIG testing community. It is used to help manage open source contributions to Kubernetes. They were starting to adopt Bazel and rules Docker. And so I wanted to see, this also runs on Kubernetes, by the way. I wanted to see this in action with a non-trivial Kubernetes application. And this was a nice application for me to kick the tires with. So you can see it's a GitHub bot. It's running as Matt Moore sock puppet. It's labeled my PR here as extra small, and it is running some simple tests. So this also supports some basic chat ups. This is sorry, I'm not Oscar, so this is me trying to add some humor to this. Did you hear about the scientist who was lab partners with a pot of boiling water? He had a very esteemed colleague. Okay. So I stood up this deployment with everything.create. It's new every time. I had no idea what I was getting myself into. So I stood up this Prow application with everything.create, but I really wanted to see what it was like to build a feature with it. And so since I'm constantly checking in Buildifier errors, I wanted to add a Buildifier plugin to Prow so that when you ran /buildify, it would run Buildifier over it. So this is a little slow because it's cloning the repo for the first time. It has a cache, but you can see here, this Bazel file needs formatting. Please run, okay, I'm not that polite, I guess. Run this command. Okay, so if we switch over to the VM, you can see, hopefully you can see this because this is on the largest font. There are 5 pods running the different components of Prow on my Kubernetes cluster. These represent the 5 deployments. Let me just go through my list here. Okay, so you can see all of the components in this starter cluster directory. There are actually a whole bunch more pieces of configuration and whatnot. These actually exist. So there's a couple objects for secrets that exist outside the repo that we're pulling in through a local repository. This is the part of the demo where I have to ask Laurent to cover his eyes because I'm going to show you my messy build file. So I'm jump down to the end. You can see I'm using very similar groupings here to what was in the slide. There's an everything group that I used to stand it up. There's also a secrets group, a deployments group, a config maps group. And then because there's so many objects, I used some for loops. Sorry, Laurent. You can see the secrets coming in from the external repo. And then most of these are pure config. The exception to that is the deployment object here, which for each of deck, hook, horologium, I think I'm pronouncing that correct, plank, and sinker, we have, I didn't name them, I swear. We also have this images attribute, which is using this dictionary up here, to say, hey, in the hook.deployment.yaml template, the image reference is something like gcr.io, k@sprow, hook, and then a tag. And we point that at prow cmd hook. OK, so let's see. Well, one more thing before we see it in action. I wanted to show you what it looks like if I just run the target. This wasn't an action I specifically talked about, but it's worth mentioning. So now when I run the target, this is the template that will feed into all of those actions. This built the hook component, published it to the registry, and then embedded the reference to the exact image we pushed into the template in place of that tag. And so the reference was gcr.io, k@sprow, hook, some tag. There is now a digest reference in there that makes sure we have a very strong sense for exactly what we just pushed. But we have also pushed it somewhere else completely. So I actually don't have access to this repo. And this may reflect a sort of developer environment sort of feature, because I may not want my developers to fat finger pushes to prod, right? And so this enables developers to push to a repo, or contributors to push to a repo to which they have access and to which their cluster has access during development, and then use those same or similar templates to run that in production against official released images. So let's make a change. I'm going to apply this. So we're going to make the little Bazel bot, or sorry, the Prow bot that runs Buildifier, add a little hi BazelCon shout out in the comments it leaves. And let's see, hook, deployment. OK, so now I'm going to try and talk through what this is doing. And I'm going to probably Alt-tab a whole bunch just to show you I'm not talking over it being really, really slow. And then I'll go back through and I'll explain it. So this is building the Go binary, sticking it into a Docker layer, publishing it to the registry, sticking that into the YAML template. And it is, then redeploying it to build redeploying it to the Kubernetes cluster. And as you can see, I typed get pods as quickly as I could. It is already up and running. 4 seconds, 3 seconds in Bazel. And if we switch over here, hi BazelCon, right? So fast is my goal. And so it was actually really fun. I now use these every opportunity I get because it's so much fun to just throw things over the wall that fast. So one more thing I wanted to show before handing it over. So that took 4 seconds. How long do you guys think it would take to replace all 5 deployments?
10 minutes.
4 seconds. I was hoping you guys would go 20. 4 times 5. OK, 30 seconds. 4 seconds. I don't think it's quite that good. So this 4.5. OK, so a lot less time was spent in Bazel this time, but basically what this was doing is pointing at Bazel's reproducibility and the benefits of reproducibility to doing this fast. Excuse me. If I get pods, only one of them changed because the image reference has only changed, 26 days ago, right? I've been practicing quite a bit, right? The image references, aren't changing because, it's broken. It's not changing because every time I rebuild, it's producing the same digest for the Docker image. And so basically, that 4.5 seconds was making sure the registry had all 5 images, running kubectl replace. But for 4 of the 5, it was like, well, that's exactly the template I have. I'm not going to do anything. And then for that last one, it moved the tag back to what it was producing, pointing to what 10 minutes ago, and then basically rolling back out the change to return it to the earlier version. So with that, I am going to hand things over to Miles. And all right.
Awesome. Yeah, thank you so much, Matt. That's like such a cool demo, and I'm like really, really excited to start to play around with some of these new Kubernetes objects rules at Databricks. OK, cool. So nice little segue. At Databricks, everything that we do is on Kubernetes. So just to introduce a little bit, like we have a bunch of Kubernetes clusters running several terabytes of memory and hundreds of cores. We use it for all of our production services as well as basically all of our development services as well. And like Matt pointed out in his presentation, we also leverage JSON really, really heavily. We have a blog post about this on our blog. You can go take a look at it if you want to. But we also really love Bazel. The heart came out a little bit interesting, but yeah, anyways, if you were here yesterday, you heard Ahir's talk about how we used to use SBT at Databricks to build Scala, Java, JavaScript, and it was really sad face times. Like, it was so miserable. And over the course of last year, we switched over to Bazel, and which meant we went from only 2 people being able to make any kind of meaningful change to the build to basically anyone can add new build targets. It's very flexible. Like, every team is empowered to do something new with the Bazel build. And we've kind of coined this, or we call it internally, like democratizing the build. I think I've heard this term also out here too. That is like so important at Databricks, that any change to the build now is not gated on the build experts. Anyone can really come in and say like, oh, I'd like to add a new target to build my new Scala stuff. Like, great, that's like really super easy. Or I want to build a new rule, for instance, to deploy my new infrastructure in this cool way, which is what I'm going to talk to you about today. And I'm not a build engineer. I'm just like a normal software engineer. I like looked at the Bazel documentation, talked to Ahir a lot, and kind of figured out like how, if this was like kind of a feasible thing, and got to put together this rule that I'll tell you about, and it's been really awesome. So hopefully that's like inspiration to all of you, also non-build engineers out there who are inspired by to use Bazel to do some kind of cool deployment stuff. So yeah, just to kind of touch on the issues that we face at Databricks. So deploying can be like a lot of manual work, and manual work for things that touch production is like really not pleasant at all. Especially one thing that we've observed is that a lot of our services we're trying to scale out over many different regions, over different clouds. You have dev, staging, production that are all separate. You have different things for different users that are separate. And it just is really cumbersome. There's a lot of like manual typing out, or you can kind of put things together into shell scripts, but those are also really hard to maintain. And it turns into that basically the operator has to do a lot of like kind of manual work. We have like big wiki pages internally of like how somebody went to update something at Databricks, and it was really kind of unpleasant to go through and make sure that those were up to date. And every time there was a change, we'd have to like go back and fix those wiki pages, and sometimes we would forget, and new people coming on like learn old it's like a mess. And not only that, but it's also, we found really nice to have kind of internally, like have some things that run kind of on master all the time. That way you can get a good sense of like what the current, like, like fresh off the press version of your services are. But if you don't have any kind of process or practice to make sure that that's up to date, then that can be really old. And we've also had problems where we didn't know, this thing, the service is like a month, 2 months old, and can't use it for any kind of reliable like testing or figuring out like what the current state of affairs is. So yeah, that's one half. The other half too is like when you're pushing to production, you care about like auditing. You want to see, who's done what, what version is a thing running? When was it last updated? Like who was the person that updated it? Is there an update happening right now? There's a lot of kind of visibility stuff that you don't really get just from like, running thing on the command line. You have to maybe like go to Slack and say like, oh guys, by the way, I'm updating our production web app, like just so you know. So, but that doesn't scale, and like, might easily forget that step too. So basically what we wanted to do was like make this a whole lot easier and make it scale really easily. So we wanted something that was really automatic, one button push, and you could just kind of accept that the update was going to like work properly, or if it didn't, you would find out about it and have a way of kind of addressing that problem. It should be also really easy to set up and use. So we really wanted to make it possible for other people at Databricks to kind of leverage this, infrastructure to deploy their own services. Okay, yeah, one note that I didn't touch on exactly earlier, but I think is important to mention is that for many of the teams at Databricks, each team is responsible for their own rollout. So like my team, not only do we develop our services, but we also deploy them and monitor them, and kind of are responsible for the whole life cycle of these applications. So for us, it's really important to make sure that each team is like has the ability to leverage this kind of deployment infrastructure with the least amount of friction possible. So I was hoping to build something that was like easy to use this way, that anyone could kind of like figure out and get working in their environment really quickly. And we'd like it to be integrated with Bazel because there's a lot of cool things that Bazel does, and like I thought that would be it'd be really fun, and also give us like kind of full circle integration, like a thing that can be tested and a thing that we can rely on to like produce the right kind of infrastructure for us. So what we came up with was this application rule, and basically, this is a build rule that has a special guest star of Jenkins. If you guys are, deploying things, basically, you might be using Jenkins, so this is a pretty common setup. Yeah, so on the left side, you'll see kind of what it looks like to use this rule. It's actually really dead simple. It has a very limited number of parameters. It's like 5 lines in your build file, and it does all these things that you want. So you pick a name for your service, or in this case, I said my service. You pick a Slack channel that you'd like to let you know about things that are going on. We also support kind of this interesting feature of like production, like canary groups. So you like roll out something to one production a location first before other places. And then maybe if you would like, you can opt into like periodically updating your service in development every morning, which is what we have here. And that's it. And with this, you kind of get a easy to use Jenkins job to update your services across all of your environments and with no hassle. We're running a little bit short on time, so I'm going to try and go through this sort of quickly. But basically, there's like 4 simple steps to using this thing. The first is we compile what I call a list of update groups. This is essentially kind of a mapping of, like a regime of deployments to the specific environments that I'm deploying into. So for in our case, because we're doing everything on Kubernetes, this turns into like the set of Kubernetes clusters that I'd like to run my application on. So maybe you want to kind of have some moniker like dev that means to deploy something to all of your development clusters across everywhere, or you want to deploy just to your staging AWS clusters or something like this. And so we have these kind of abbreviated list of groups that we're deploying to. That's step 1. Step 2 is to produce and check in an XML file that describes the Jenkins job. This is like kind of a standard in the Jenkins world that you can describe your Jenkins infrastructure using XML. And then upload it to Jenkins, and then everything's magical happiness. Yeah, let me just really quickly go through. So what it looks like at Databricks is we use JSON-it, and so all of our deployment templates are JSON-it, and they're laid out in this kind of interesting way where we're able to kind of separate kind of the cloud that we're deploying onto, the environment that we're in, region that we're in by different directories. And what this allows us to do is to kind of programmatically construct the Kubernetes context or cluster that we're going to be launching something into just by looking at its path inside of this directory. And as a result, it becomes really easy to construct this kind of set of contexts that we'll be deploying things into with this infrastructure. And so here this is like, you have dev, staging, prod, and maybe you have like a group 1 and group 2 for production, and that's kind of illustrated here in this JSON file. So this is one action in Kubernetes produces this, or in Bazel produces this JSON file. The next thing is to kind of convert this into XML file for Jenkins. This is, basically a really simple, uses this thing called Jenkins Job Builder. This is an open source tool. I have a link to it on the last slide. And then the last thing, so this XML file, one important part is that this is actually checked in, and there's a test that makes sure that this XML file is generated in the same way from what's checked into our repository. And that makes it really easy to enforce that the Jenkins job that is running on Jenkins is actually able to deploy the infrastructure that's checked in. Because if you add a new cloud, you want to make sure that you have the option to deploy to that new cloud. Or if you add a new region, or new kind of grouping, you want to make sure that you can deploy to that grouping. So having this checked in makes it really easy to ensure that somebody, when they make a change that affects this job, they'll also check it in and upload it to Jenkins. So yeah, and then the last step is to upload it to Jenkins, and we've kind of made this convenient by adding like a simple Bazel run command that just kind of makes the right API calls to Jenkins and puts it up there, and you get a little Jenkins job that allows you to deploy your thing. So yeah, basically, why is this awesome? One thing is that we've discovered is like as we add more and more regions, it was originally like more and more work for a deployment operator, but now it's automatically picked up by the Jenkins job. The job doesn't change if you add a new region, as long as it's deploying within the same kind of staging or staging in the cloud. So this job doesn't change that much, but it automatically can deploy to all the different regions that you support. If you add a new scope, dev, staging, and prod, or cloud, like I said, we'll automatically generate a new kind of input in Jenkins. We'll make sure that that new job is tested properly, and we'll generate the script to upload it really easily. And then we can also automatically update dev, so there's no code rot. That's a kind of a little thing, but it kind of adds up in the long run, I guess. It's audited, which is really cool. So you can see historical or current runs in the Jenkins job UI. And with the Slack integration, it also kind of pushes out notifications to our team so that everyone on the team finds out about if there's an update that's happening. And so this is kind of an example of what it looks like at Databricks. This is one of our Jenkins jobs that we use to update a service that we call the central service, which is a stupid name for service, but that's beside the point. Anyways, you can kind of see you have even statistics about how long it takes to do different parts of the update on the kind of bottom right-hand side. On the left side, you can see kind of historical runs, and you can see who's triggered them and the outputs of each of those job runs. So that's really nice. And then we get kind of these Slack messages that say, like, so-and-so, in this case, this is like our automatic updater, Jenkins, is updating, a Service Central in our development AWS contexts. And then it tells me what image I'm using to when I'm deploying this service here. And then also, it's really easy. You only need to add one Bazel target. So anyone can do this. They basically take 2 minutes of their life to learn how to use this rule, plop it into their build file somewhere, and then can automatically start leveraging this cool deployment stuff. So yeah, that's all that I got. I want to just say really thank you to the cloud team, the growth team, and build team at Databricks, and especially here who's here presenting, and Aaron Davidson. And also for Jules Damji for helping review this presentation for me. So.
And I wanted to make sure to thank Dan Lawrence and Matt Rickman, who have been contributing to the Bazel rules, as well as building out some of the distro list stuff, as well as Damian from the Bazel team. Mm-hmm. So we'll open things up for questions. We have a wall of links that we'll just leave up while we answer questions.